All right. Today we're going to be taking a look at similar figures and proportions. It says the octahedral fluorite is a crystal found in nature. It grows in the shape of an octahedron, which is a three-dimensional figure with 8 triangular faces. The triangles in different sized fluorite crystals are similar figures. Similar figures have the same shape, but not necessarily the same size. The symbol, squiggly there, means is similar to. Corresponding angles of 2 or more polygons are in the same relative position. Corresponding sides of 2 or more polygons are in the same relative position. So what does that mean? Okay, similar figures. To be similar means you are the same shape but different sizes. So you need to add the word similar to your vocabulary list. Corresponding angles, when we were talking about triangles, I talked about, look for the largest angle, and that the largest angle is across from the largest side. Look for the smallest angle. The smallest angle is across from the smallest side. Well, when you are comparing two triangles of different sizes, to see if they are similar or not, you want to compare largest angle with largest angle. So in this case, 82-degree angle to 82-degree angle, medium-sized angle to medium-sized angle, or 55 to 55, and smallest angle to smallest angle, the 43-degree angle to the 43-degree angle. And you can see that when I put the corresponding angles, largest to largest, medium to medium, smallest to smallest, that all of the angles are the same size. The corresponding angles are congruent. Corresponding sides mean I'm going to compare the smallest side to the smallest side, in this case 32 to 48, the medium-sized side to the medium-sized side, and that would be 38 compared to 57, and the largest side 46 to the largest side 69. So when I compare corresponding sides, I want to compare smallest to smallest, medium to medium, largest to largest, and the same is true with angles. So please add corresponding angles and corresponding sides, as well as similar figures, to your vocabulary list, because those words were not in our textbook. These are coming from a supplementary textbook. Let's take a look at the example here. This is on page 300 in the blue textbooks. It says, tell whether the triangles are similar. It says the corresponding angles of figures have equal measures. So take a look as I compare the smallest angle to the smallest angle. I see that they are both 34 degrees. I compare the medium-sized angle 40 degrees with the medium-sized angle over here. They're both 40 degrees. And the largest angle 106 degrees with the largest angle 106 degrees. Since those corresponding angles are all equal, then I know that these two triangles are actually similar, because I don't really need to compare the sides if the angles are congruent. This is a special trait of triangles. But I'm going to go ahead and do it anyway. When I compare the smallest side to the smallest side, I get 7 on the smaller triangle and 21 on the larger triangle. If I compare the medium-sized sides, I get 8 on the smaller triangle and 24 on the larger triangle. And I'm just writing these as ratios. When I look at the bigger triangle, I have 12 on the smaller triangle and 36 on the larger triangle. And the question is, are they equal? Well, the easiest way to compare them to see if they're equal is actually just to reduce them. 7 goes into 21 3 times. So 7 over 21 is the same as 1/3. 8 goes into 24 3 times. So 8 over 24 is the same as 1/3. And 12 goes into 36 3 times. So 12 over 36 is equal to 1/3. Since those are equal, that means these are equal, which means our two triangles, triangle DEF, let's go in alphabetical order, is similar to triangle QRS. Take a look at this. It says, with triangles, if the corresponding lengths are proportional, then the corresponding angles must have equal measurements. So the reverse is actually true as well. If the corresponding angles have equal measures, then the corresponding sides are proportional. So with figures that have 4 or more sides, if the corresponding side lengths are proportional, then the corresponding angles may or may not have equal angle measurements. Take a look at this. I can see here in the center a small rectangle. And I can tell you that one of the two shapes, to either its right or left, is similar to it. You probably can tell which one's the similar one. It's the rectangle. The other one, which is a parallelogram, is not going to be similar because of the angle measurements in it. But here, if I wanted to compare the ratios of sides to sides, I can take the small side of 5 centimeters and put it over the small side of 4 centimeters. And I can take the large side of 10 centimeters and put it over the large side of 8 centimeters. When I reduce that, they both reduce down to 5 to 4, which is equal. So the corresponding sides are equal. In addition, I know that all the angles of a rectangle are 90 degrees. So therefore, corresponding angles are also congruent. But let's take a look over here. If I compare small side to small side, I get 5 to 4. If I compare large side to large side, I get 10 to 8. We know that those are equal because those are the same ratios we had when we were comparing the others. But we know that these two quadrilaterals are not similar because over here, these angles are acute and these angles are obtuse. But in rectangles, all the angles are 90 degrees. So these two figures are similar while the other one is not. So what does this mean? When looking at quadrilaterals, you need to look at the angles first. Then you can look at the sides. So don't bother looking at the sides until you've made sure all corresponding angles are congruent. So over here, I have a 45-degree angle and a 45-degree angle. I have two 90-degree angles and two 90-degree angles. I have a 135-degree angle, and over here I have a 135-degree angle. It passes the angle test. You've got to pass the angle test first. Then we can compare the sides. So I'm going to erase all these circles so we can get a cleaner look at this. What is the shortest side length on the first rectangle, or the first quadrilateral? It's 10 feet. And actually we have two of them that are 10 feet. Over here I have two sides that are 4 feet, which are the shortest sides. I'm only going to do one ratio of 10 to 4, because 10 to 4 is 10 to 4 whether I write it once or I write it twice. Then I look at the next shortest side, which is 15 feet over here and 6 feet over here. So I'm going to put 15, the first shape, over 6, the second shape. Notice how I always do the shape on the left on top and the shape on the right on the bottom. I just think it's best to be consistent that way. I think you will be successful if you do it that way. So that leaves me with the largest side, which is 20 feet for the left shape and 8 feet for the right shape. And again, putting the left side on top and the right side on the bottom. Now I need to ask myself, are these equal? 10 over 4 reduces to 5 over 2. 3 will go into 15 5 times. 3 will go into 6 2 times. 4 goes into 20 5 times. And 4 goes into 8 2 times. So they do all reduce to 5 to 2, meaning that the corresponding sides are proportional. That means these two are similar. So I can say trapezoid E, F, G, H is similar to trapezoid LMNO. So the two trapezoids are similar. That takes you up to the guided practice here. And so what I would like for you to do is to go ahead and do 1, 2, 3, and 4 here on page 302.